A very good morning to you guys. Today we are going to continue with architecture. Now, what is an architecture? An architecture defines how function works. So it defines how something works or functions. Okay? That's an architecture. It simply defines how things work or function. So today we need to look at the architecture of a computer. Okay? Architecture of a computer. Okay? This is what we need to look at today. So basically we have two types of architecture. We have two types of architecture. But today I'm going to speak much about the one of them. And the two types are: number one, we have what is called the von Neumann architecture. Okay, number two, we have what is known as Harvard architecture. Okay, so these are the two types of architecture that we have in computers. Okay, now let's look at the von Neumann architecture. Okay, we need to look at this one in more detail. Now, von Neumann architecture was designed by a designer, mathematician, and scientist known as von Neumann in 1945. Okay? So it was designed in 1945 by a scientist von Neumann. Okay? So the guy was called von Neumann. That's why it's called von Neumann architecture. And if you are to look at it, you realize that most of the of the computers today runs on von Neumann architecture. Okay, especially the mainframe computers or personal computers. Okay, they run on this architecture. They run on this architecture. Okay. Now, here is the architecture. I'm gonna explain. Here is the architecture. Okay. So we are saying we have the input here. We have the input. Now, as the input comes in, it is stored in memory. Okay. And the memory will send the commands where they are processed. So in the process, there's the CU and the ALU. CU and ALU. So CU and ALU has got a relationship. So this is a two-way relationship. So what happens is, as the input comes in and stored in memory, the commands are sent with this bus. Okay, because processes process instructions from memory, and when they are processed, they are stored back in memory so that they can be viewed as output. So in the process, we've got the CU. CU stands for control unit. And what the control unit does is it manages the commands and input output. It manages commands and input output. Or shortly it is written as IO. Okay, that's the function of the control unit. And we have the ALU, or the arithmetic logic unit. Okay, this one, what it does is it performs mathematical functions. This one is responsible for performing mathematical functions. Okay, so the the ALU performs the mathematical function. So what happens is, as the input enters, it's stored in memory, and the process takes commands from the memory to process them in the control unit. And the control unit, since it manages the commands and input output, they are sent to the ALU for calculation, and they are sent back to the control unit, and from the control unit they are sent back to the memory and displayed as output. Okay, so basically this is the von Neumann architecture. Okay, so let us look at the components now. Now we need to look at the components. Okay, so the first one, we have input. All right, input refers to all devices that are used to enter information in a computer system. Okay, so this includes things like keyboard, mouse, etc. Okay, that is it about the input. They're just mediums through which information is entered into a computer. Then we move to the second component, the memory. Now, the memory, we are saying this is where data is temporarily stored in memory. Okay? Data temporarily stored there. Okay, so data is temporarily stored in memory, and the memory is called RAM. RAM means random access memory. Okay, we move on to process. Component number 3 is process. So we are saying in the process, we have about two components inside the process. The first one, we have got the CU, or the control unit, which manages the commands and I/O, or input output. Then we have the ALU. I'm sure I once mentioned about this. And we are saying the ALU performs mathematics functions, for example, addition, subtraction, multiplication, division, etc. Okay, we move on to the last component, which is output. All right, now this one, we are saying whatever that has been processed is displayed through the output using things like the monitor, the printer. So you can say responsible for display. Okay, e.g. we have monitor, we have things like printers, etc. Okay, now we need to look at a practical example of what I'm talking about. Let's look at an example. Okay, now we enter 20 plus 20 through the keyboard. Okay, we need to enter 20 plus 20 through the keyboard. So here we go. This is our keyboard. And we enter 20 plus 20. Okay. So this is regarded as input. So we are saying it goes to memory. Okay, and from memory it's processed here. We have the control unit, we have the ALU, so from memory it goes to the control unit and then sent to the ALU for performing the addition. Since the control unit is the one that manages the command, so the command is sent to the control unit, and the control unit will send it to ALU for performing addition. And after the ALU finishes with addition, it sends back to the control unit, and the control unit will then send back to memory. Okay, and this is displayed as output 40. All right, so these are the steps involved in performing a calculation. All right, so I can say this marks the end of this lecture today. Thank you very much for watching. I hope and trust that you have enjoyed this tutorial. If you have any questions, please don't hesitate to let me know at 0784 002 002. My name is Takud Kakuoni. Goodbye.